Hey folks, so I am making this little tutorial video just in case you need a refresher on how you can determine who the parents of our cubs are. Okay, we got cub 709, 710, 711, 712, and below 713. Okay, and we're trying to figure out who the parents are. Why? Why do we care who these parents are? Well, we want to know how traits are inherited, okay? Physical and behavioral traits. We know that traits are the same as genes, right? A gene is a trait that is passed down, a trait that is inherited. Some traits are adaptations, beneficial traits that allow organisms to survive within their environments, okay? So what we're going to be doing is we're going to be looking at genotypes, okay, which are the literal genes of traits that we're looking at, okay? If we were talking about a phenotype, then we'd be discussing what that trait represents that we could observe. So an example of that would be the genotype, or the gene for the color of your eyes, we'll just call eye color. But you can have different variations of that eye color, right? I mean, you can have blue eyes, you can have brown eyes, you can have green eyes. There are loads of different colors, but the point is that you can have different variations of that same gene, which is eye color. Those variations come in the form of a word called alleles, okay? And you get 2 alleles per gene. You get 2 alleles per gene because you have a pair of chromosomes, right? You have 2 chromosomes. One comes from mom and one comes from dad. In this case, we're talking about lions, so we're talking about the father and the mother lions, right? 2 alleles, they're all on the same gene, but they're just different versions of that gene, okay? And we even have our different genes listed here, like FCA26, FCA45, FCA77, and FCA96. I'm just going to refer to these as 26, 45, 77, and 96. Okay? Just to not repeat FCA a million times. So, how do we go about figuring out who our mother is and who our father is of cub 709? Okay? Well, what we can do is we can take the genotypes, we can take the alleles, the exact alleles, and compare and contrast which alleles the father and the mother must have. If the father and mother have the same alleles as our cub here, which we have listed right here, right? Well, then we can probably make the claim of who the father and the mother are. So again, if it's not clear, our cub is here, cub 709. On gene 26, they have the alleles A and C. On gene 45, they have the alleles M and M. For 77, S and S, and for 96, D and D. Okay? So if I wanted to figure out who the mother was of this cub, then I would expect to find in these boxes that I'm about to fill out the same alleles as our cub, right? Because mother's going to donate 1 allele and father's going to donate 1 allele. So let's just try and work this out. Let's try and work through 709, okay? Just cub 709 here. And our first potential mother is 628, okay? Well, how do I figure out what alleles mother 628 has on gene 26? I'm going to look back here at my chart here on the left as a reference. Well, there's female lion 628, there's gene 26, and what do you know? There are the alleles. So, I'm just going to write AB. What about for gene 45? Okay, well, for 628 on gene 45, if I look here again, then I should get MN. And the nice thing about this table here on the left and the table here on the right is that we can kind of just copy paste over, right? So AB, MN, what do you know? SS for 77, and for 96 I get DD. Okay? So there's all 628. What about 630 and 687? Let's see if either of these two could be the mother. All right? So again, I'm just going to literally copy over the genotype data onto this side of the table first. So I'm going to go BB, MN, SU, and EH. And then for 687, I got right down here, CC, MN, TU, DG. All right, perfect. Okay. Now here's the thing. We don't really have any data that we can work with here to determine who our father is, okay? I don't know who the father is. I mean, we have potentially five different male fathers here, okay? So let's just deal with the mother first. And by deductive reasoning, whatever our remaining allele that isn't donated from the mother has to be coming from the father, right? Because each parent donates one allele. For example, in gene 26, Cub 709 has the alleles A and C. A could come from mom, A could come from dad, but I don't know. Or it could be the opposite. It could be C. Maybe C comes from mom, but like it could also come from dad. That's what we're going to try and figure out here. So just looking at 628, okay, I have a highlighter out. I recommend taking out another color, or you can underline, whatever works the best for you. Is we're just going to compare and contrast alleles now, right? I want alleles to match with each other. So I know if 628, one of our possible mothers, could be the mother of Cub 709. Well, on gene 26, Cub 709 has the alleles A and C, while our mother, 628, has A and B. So could we make the claim that mother 628 donated the A allele? And the answer is yeah. We could, right? There they are. Our A allele was donated from mother here on 628. Wonderful. What about on gene 45? 628 has MN. Our Cub has MM. You could definitely say that M was donated from 628. Same even for SS here, right? And even the same for DD. So conveniently enough, actually, you could actually just say right here that 628 is the mother. Okay? Because, look, every single allele that showed up in the Cub also showed up in the mother, right? And that's the only requirement that we need to reach, is that all the alleles match. All right? I do want to show why 630 and 687 don't work, okay? I mean, let's just look at mother 630. Does mother 630 have either the A or C allele? No, right? It's BB. I'm going to circle everyone that does not work out. So I already know right off the bat, I don't even have to do any more work, but I already know that 630 cannot be the mother. The mother cannot be 630. You know, another good example of this is, I mean, look at gene 96 here. 630 has EH, but our Cub has DD. I don't see a D anywhere here. Okay? So, again, 630, it's just not possible. What about 687? Well, I mean, look. 687 has C here. Mother has C. So far it's working out. What about on gene 45? MM still works out. What about when we get to gene 77, though? SS. Well, 687 doesn't have an S. So I already know now that 687 cannot work out, right? It can't. So mom has to be 628. All right, now how do we go figuring out who our father is? We know that mother donated these alleles that I highlighted in orange, okay? But there's still an extra allele. Those extra alleles come from father. All we have to do now are to use these alleles to figure out which one of our males it may be. So I'm just going to write the remaining alleles in here first, okay? And I'm pulling that from these boxes right here. The ones that I did not highlight in orange are now showing up here, okay? But we can't figure out dad yet because we only have one allele. Let's look over at our males here, our potential males. Well, dad has to have CMSD in that order, okay? So it has to go CMSD in this order. What about 633? Well, there's our C. Oh, I don't see an M. I see the letter N, but not the letter M. So it can't be 633. What about 631? Well, no C on gene 26. Not possible. What about 695? Well, there's a C, so we're doing good. Now we need to have an M. Oh, no M on 45, right? No M on gene 45, so 695 is not going to work out. What about 668? There's our C, right? There's our M. There's our S. And what do you know? There's our D. So dad is probably 668. And that's all you got to do. That is all that you got to do. I will say before ending this video, the only thing you should know is that these boxes for dad don't have to just be a single letter. It is possible that maybe you get it is possible that you get two potential alleles in the same box, okay? More likely than not, you will have just one allele in these boxes, but it is possible to get two, which means that it could be either or allele. All right? I hope that was helpful to you. The rest of the page, you are just following the same exact procedure. And look, the nice thing for you is that these boxes right here, all these boxes are the same data from over here. So you can literally just copy paste those boxes into every single one. It's a little bit annoying to rewrite out, but the nice thing is that I don't even have to look at the sheet. I can literally just take all these and paste them back into here. You'll still need to figure out the father's genotypes, and you'll still have to figure out who the mother is based on the genotypes of the cub, but at least these boxes right here, okay, whatever you want to call this, a 4x3, you literally are just copy pasting because it is the same exact data that I gave you over here. Hope it was helpful, folks.